In New York, I barely riding in my socks off. And I shoot that hawk. And I'm on the block. And I'm on the block.
Okay, today let's discuss the work that Madam just gave us.
Sure, let's get started. Alright, let's get started.
Okay, for the first question. Question 1. What is the meaning of differentiation? Differentiation is the rate of change of a function. The concept of it is y equals fx. We'll differentiate it. It becomes the derivative dy over dx, also known as f inverse x. Rate of change is also known as gradient, which is how quick the rate of change is. If we have a curve, we can find how quick the rate of change is by the tangent point of the curve. For an example, my tangent point here is x, which is equals to 2. Fx equals to x squared plus 3x plus 2. We'll differentiate the function. In f inverse, it becomes 2x plus 3. Then we'll substitute the value of x with 2. Then we'll get our gradient as 7. In conclusion, the gradient of a point is determined by the tangent point of the curve. What are the techniques of differentiation? The first one is derivatives of constant linear and power function. The second one is derivatives of sum and differences. The third one is product rule. The last one is quotient rule.
Alright, move on to the next question.
Alright, so question 2, given the question is find dy over dx for the following function. So the function is 3x squared sec x plus 2. So the first step is you need to know the product rule formula, which is d over dx, u multiplied by v equals to u prime v plus uv prime. So let's assign as u as 3x squared and v as sec x plus 2. Right, so the first step is you need to differentiate the 3x squared, which is 3x squared, the power of 2 you need to bring in front and let like this 2 3 x power of 1, because this one need to minus 1. Right, so the answer is 6x. So the u prime is 6x, while the v after differentiate will be the sec x plus 2 tan x plus 2. Right, so after that we need to bring this uv and uv prime into the product rule and became like this. So this is your final answer. Alright, let's move on to the next question, which is 2b. So given the function is y equals to 4x plus 2 over cos x. First thing first, we need to know the product rule for this function, which is d over dx. U over v equals to u prime v minus uv prime over v square. So let's assign u as 4x plus 2 and v as cos x. Alright, to get the u prime and v prime, we need to differentiate these two. Alright, so let's differentiate the first one. After differentiate the 4x plus 2, we get 4. And after we differentiate the cos x, we will get sin x. Alright, so after we get the u prime and v prime, we can apply this to the product rule, and we will get this. After that, we solve this question first, and we will get this. After that, so here is our final answer.
Okay, for the next question.
Given the equation y natural log of 3x minus e to the power of 2x plus 1 minus tan of y equals 0. First, we differentiate each of term with respect of x. For the first term, by using product rule here, we get y over x plus natural log of 3x dy dx. For second term, we're using chain rule here, we get 2e to the power of 2x plus 1. For third term here, by using chain rule 2, we get 4x squared of 4y dy dx. After that, we group all the dy dx term on one side. Now, we divide both sides to isolate the dy dx. Then the final answer will be 2e to the power of 2x plus 1 minus y over x over natural log of 3x minus 4x squared of 4y.
Okay, for the last question. Question 4. Use linear approximation to estimate the value of 4 square root 80.99 minus 2 over square root 80.99. Correct to 3 decimal places. First, we'll find fx for each of the function given. We'll substitute the value of 80.99 with x. Then, we will get 4 square root of x minus 2 over square root of x. We'll simplify each of these functions. We will get x 1 over 4 minus 2x negative 1 over 2. Then, we'll need to differentiate each of these functions in our f inverse. We'll bring 1 over 4 in front of x and we'll minus it by 1. We will get 1 over 4x negative 3 over 4. We'll inverse our symbol becomes plus. Negative 1 over 2 we'll bring in front, which cancels the 2, becomes x. And we'll minus negative 1 over 2 with 1. And we will get negative 3 over 2. We'll simplify each of our function into positive quotient, which is 1 over 4x 3 over 4 plus 1 over x 3 over 2. Then we need to find our x0, which is 81, because it's the closest value to 80.99. We'll find our delta x by using this formula, x minus x0. Then we will get our delta x, which is negative 0.01. We'll use all of our value here in this formula. We'll substitute x0 with 81, our delta x with negative 0.01, our fx0 with 81, our f inverse with 81, and our delta x with negative 0.01. Then we bring our fx function into our f, and we bring our f inverse function into our f inverse. Then we'll simplify using our calculator. Then we will get the answer f 80.99 approximate to 2.778. We need to use 3 decimal places as the question stated. In conclusion, we've explored several key methods like product rule, power rule, quotient rule, chain rule, implicit differentiation, and logarithmic differentiation. All of these key methods are used depending on the function structures. Power rule is used when differentiating expressions of the form x to the power of n. Product rule is used when differentiating the product of two functions. Quotient rule is used when differentiating a quotient of two functions. Chain rule is used for composite functions. Implicit differentiation is used when functions are not given explicitly in terms of one variable. Logarithmic differentiation is useful for differentiating functions with complex exponents or products.